And now we're back with another electromagnet, which is actually a switch powered by an electromagnet. So I'm going to take the cover off. And what you've got here is two switches. This is a two-pull. There's a pull and a pull. They are not electrically related, though they are mechanically related. Now they are single pull, double throw. Same as what you have on this switch here. Common in the middle, one side, the other side. In the case of the relay, common is back here. You have a flexible copper braid, and there's your contacts. There's an upper contact with this terminal and a lower one, and the blade is back here. So it's either connecting with the upper or the lower. Now, shall I bring this up? So it's going to go up and down. So what I'm going to do is I'm going to power this with an independent power source. Put a wire. Now these two wires on the side are the coil. Now there's a coil in there, just like we got coils here, and they're pulling a steel clapper. Let's see, black wire. Now watch closely. When I apply power, the relay changes state. Relax, it changes back. So this is what they call the relaxed position. So this contact up here would be known as the normally closed. And the one at the bottom is normally open, which means when it's unpowered, that's when that state applies. Normally closed, no power, switching to close the lower one. So there are two circuits being controlled here, and they can be completely different electrically. This could be 12 volts, that could be 24, or this could be high voltage. They don't talk to each other. So now I'm going to hook this up to the light bulbs, same as I did with this single pole double throw switch. So I'm going to get a power these two light bulbs over here, which we've already seen. And white wire. And power to the common. So I'm only using this side of the relay here. I'm leaving that alone. So, powering it up, I need a positive wire going to the common on the light bulbs, to the lights, turning on the power. And you notice this light is on, and we're using this side of the relay. This is not being used. So if I push it manually, it switches to that one. So it goes between that one and that one as I push this down. So I'm going to power it electrically. You can see the clapper going down. Just switching circuits, just like this switch does here. Single pull, double throw. Now, if I use this one, it would be a double pull, double throw. So I use this relay because it's big. They get a lot smaller, and I'd like to demonstrate that visually if I can. Okay, here's another plug-in relay, similar behavior, but in this case it's 4 poles. This is a very common relay. Goes into an 8-pin socket, replaceable. It's a double pull, double throw, just like this, but does lighter work. And there's a manual button on the side. You can manually close it just like I'm doing here. Another double pull, double throw, same as this, but much smaller, lower rating, voltage and amperage. There's one of them with the cover off. I'm not sure if you're getting that, but another very small relay. I use this to power an air solenoid on a gag. Double pull again, double throw. And what else have we got? An automotive relay. A lot of relays in cars plug in. They get tired and burn out. This one here, this is a really unique relay. It's known as a rotary relay. And there's a solenoid that causes a wheel to turn, and it moves the positions of the contacts. So I made a clock with one of these. And each pin was a different hour of the day, and then there's a reset button on the side that sets it back to 0. I think whatever I got left here has pretty much been seen, so that's my introduction to relays. And what they do, a small amount of power like that, like a quarter of an amp of power to switch it, can turn on 80 amps of power. So a little button somewhere can turn on a great big machine. That's what a relay does. Okay. Here we are with the Bowmanville Lampegoid. This allows me to go 0 to 120 volts and 0 to